Hello again. This is the previous picture that we did for the ray diagram. I'm gonna repeat it very easily. The horizontal line is said to be the mirror. The dashes down there means this part is not reflecting while the other part up is reflecting. I take a point on the line on the mirror, call it I for incident point. The ray coming from the object is said to be incident ray. The perpendicular line, which is imaginary line, is called the normal. The ray coming away from the mirror is said to be reflected ray. The theta I, which is between the incident ray and the normal, should be always equal to the angle theta R, which is between the normal and the reflected ray. Today we're gonna be working with the mirror reflection. So we're gonna draw the mirror, but this time we're gonna draw that mirror vertical way. I'm gonna take this side to be the non-reflecting part. I'm gonna take a line just as my base, horizontal. This is, let's say, the floor or the table. And I'm gonna take away from it a 3 centimeters. It's very short. I'm gonna change it to, let's say, 7 to make it bigger for you and visible. 7 centimeters. This is the P. P is 7 centimeters away from the mirror. Now the image or the object, sorry, I'm gonna take it to be 3 centimeters height. I'm gonna put an arrow just to make it as upright. So the height of the object is 3 centimeters. Step number 1 is to take the first ray perpendicular. So the first ray, I will take it as perpendicular. I will always start from this point, which is the tip top of the object. Take a perpendicular line to the mirror. This ray hits the mirror in this point with an arrow of incidence as such. Because it's coming up straight to the mirror, it goes reflected back in the same manner. This part is behind the mirror, which means it's virtual. Anything I should draw in this type or in this side should be as dotted line. I will extend it and I will keep it as such. Step number 2, or ray number 2, I'm gonna take any ray, any other ray other than the perpendicular. I will take this ray up here. You can take any ray you want, down, up, it's up to you. So take any ray and draw that incident ray. Stop at the mirror. Do not continue, because incident mirror does not go inside the mirror. At that point, we're gonna do our previous work. So I'm gonna hold up the paper and switch it as such. Okay? When I switch it as such, I'm gonna use the same procedure I did last time with the protractor. This is gonna be my eye, my incident point. I'm gonna take the protractor. The center of the protractor is typically on the eye. The vertical lines, sorry, the horizontal lines of the mirror is on the mirror itself. The 90 degrees should be my normal. And I'm gonna count. So 10. I have here about 19 degrees of incident. I'm gonna do the same as reflected. So I'm gonna count from the 90, 10, and then another 9. So this is another 19 degrees reflected. You can have any number depending on whatever diagram you did draw. So for me, I'm gonna draw the normal dotted up here. And I'm gonna draw the reflected with an arrow out. As I said before, I cannot continue the incident ray inside the mirror, but the reflected ray should be continued up straight till it intersects with the other line up here. So this is the intersection. This is gonna be my image, which as you can see is also upright. If I measure it, The H prime is exactly 3 centimeters. They should be of the same size. If I measured the Q, it should be exactly 7 centimeters. The Q again is the position from the mirror to the image. And by that, I did draw the image of the object. They have the same distance from the mirror. They have the same size. Repeating, ray number 1 is perpendicular. You take a ray and it comes back again in the same direction. The extension of it behind the mirror. Take any other ray, draw its reflection using the protractor, don't forget that. Extend the reflected ray. You always extend the reflected rays in order to get the image.